For number 4 through 6, it's all about multiplying and dividing radicals. These are conjugates. Those are binomials, so only the middle sign is different. You could just type this in the calculator and get a 1, but if you want to show work, you could do the whole double distribution thing, which is FOIL, or you could just do the first and the last with conjugates. So radical 2 times radical 2 is 2, a positive times a negative is a negative, 1 times 1 is 1, and you get a 1, and that should definitely be typed into the calculator to check. So this is the process of rationalization. When you multiply anything by its conjugate, whether it be irrational or imaginary, it will become a nice real rational number. Number 5 was dividing radicals, dividing square roots. And again, the old saying is, if you're adding or subtracting, you simplify first. If you're multiplying and dividing, you suggest you divide first. So I divided the 108 and the 6, and you see they're both under radicals, so it can be done. Whatever's inside of the house stays inside. And if I wanted to write this as one big old radical, I can. So 108 divided by 6 is 8. X to the 5th divided by x to the 1st. Remember the exponent rule that when you divide like bases, you subtract the exponents. So that's x to the 4th. Then y to the 8th divided by y to the 5th is y to the 3rd. Now it becomes just a basic simplification question. Perfect up front, non-perfect in the back. 8 you break down as 4 and 2. X to the 4th is all perfect because it's divisible by the root of 2. Y to the 3rd is y squared and y. Take the square to the front, which is 2x squared y. You always do power over root, and you're left with radical 2y. This could be typed into the calculator with mock substitution. This mock substitution may be making x 3, y is 5, and it'll be an equivalence relationship. So that is number 5. With number 6, if this is a part 1 question, you're still getting them wrong, I'm incredibly sad, because if this is a part 1 question and they're asking for an equivalence relationship with something that has either an irrational denominator or with a imaginary denominator, if you just type it into the calculator, you will indeed get the correct answer by typing in all the choices to see which one's equivalent. Remember, when doing that you always type in all 4 choices, because sometimes they give you one that's not simplified. But this is a part 2, so you do have to show all work. You multiply top and bottom by the conjugate in the denominator. The reason there being is because whenever you multiply an irrational binomial by its conjugate, it will become rational. It's the whole process of rationalization. Notice on the bottom, again, you could just type this in. It breaks my heart when people get this denominator wrong, when I know all you have to do is type that in the calculator with the appropriate parentheses and you'll get a 4. But it's 3 times 3 is 9. A negative times a positive is a negative. Radical 3 times radical 3 is 3, because whenever you multiply a radical by itself, it's the radicand. This is a 2. This is a constant. If this were a binomial, I'd double distribute. But it's suggested that you don't distribute it, because if, in fact, we can simplify, it would be easier, because if we do distribute it, we're probably going to have to wind up factoring it anyway, which was the case here. You could see that on the bottom, we had, I'm sorry, not a 4, a 6 rather. I said that was a 4, it's a 6. 2 goes into 6 3 times, so this is 1 over 3. And there you go. You can't cancel the 3's because you can't cancel the plus or minus sign. If you would have distributed that 2, then you would have had 6 plus 2 rad 3. Then you'd have to pretzel it. You're doing extra work for yourself. So the golden rule is when this is a single term, a monomial, don't distribute it out and see if we can simplify it.